past the T-minus 20-minute point, T-minus 19 minutes 50 seconds and counting. A purge of the orbiter fuel cells is now underway, and the data processing engineer has confirmed the onboard computers are in the process of making the transition to the terminal countdown configuration. The primary ascent software is in Ops 101, and Commander Dick Scobee will now take the backup flight system and put it in the same Ops 101 terminal countdown configuration. T-minus 19 minutes and counting. Dumping of the Ops 101 program stored in the memory of one of the 4 redundant general-purpose computers has started. This will take approximately 7 minutes to complete, after which engineers will examine the data for any miscompares. The flight control engineer has verified the A.M.E.S.T engines are presently inactive, and the airframe engineer is in the process of checking critical aerosurface positions in preparation for hydraulic activation. Pilot Mike Smith has configured the cockpit instrument panel displays for launch, and the solid rocket motor chamber pressure readings have been registered by the orbiter's computers. Coming up on the 18-minute point in our countdown. T-minus 18 minutes and counting. The data processing engineer has reported the backup flight system is in sync with the primary system, and we're ready for Houston to transmit their pre-flight uplink commands to the backup flight system. These loads, which are sent from Houston via the Mila tracking station, put the 5th general purpose computer in the proper configuration to watch quantity levels in the reaction control system and the auxiliary power unit tanks, and do other housekeeping chores as needed.
Ready for BFS uplink. Copy
that. Coming up on the 17-minute point in the countdown. Everything going smoothly as we march through the last minutes of the count, looking for a liftoff at 11:38. Orbiter tester conductor Roberta Wyrick telling pilot Mike Smith that he can perform the main propulsion system helium reconfiguration. This will open the helium isolation valves, which will permit in-flight purges of the engines and provide an emergency sort of pressure for a pneumatic shutdown of the engines. We have a 2-hour window for our launch starting at 11:38. So the window from 11:38 to 1:38 Eastern Time at the moment. But everything going well. T-minus 16 minutes and counting.
I'd like to get the RCS quantities for left and right, please. Okay, you ready, copy? Affirmative.
Okay, forward oxidizer is 77, forward fuel is 78. Left oxidizer 9er, left fuel 9er, right oxidizer 9er, and right fuel 9er. Over.
Copy that.
Pilot Mike Smith has just reported to orbiter test conductor Roberta Wyrick on the quantities of reaction control propellants in the forward, left, and right tanks. The booster test conductor has been asked to start the gaseous nitrogen purge of the aft skirts. T-minus 15 minutes and counting. We have a 10-minute build-in hold coming up at the T-minus 9-minute point. Looking for liftoff at 11:38 a.m. Eastern Time. The prime objective of the 51L mission is the launch of the second tracking and data relay satellite. This tracking station in the sky will be boosted from the low Earth orbit of the shuttle to geosynchronous orbit, 22,300 miles above the Earth. Boosting it from the low Earth orbit will be the inertial upper stage developed under contract to the Air Force by Boeing Aerospace Company, using solid rocket motors manufactured by Chemical Systems Division of United Technologies. The IUS is 17 feet long, 9 feet in diameter, and weighs more than 32,000 pounds.
Fuel cell purges are complete at this time. We're ready for load adjust.
Copy that. EPD and ACL, step 955, please.
EPD, copy. ACL, copy.
During the 20-minute build-in hold, John Conway, who is Director of Payload Operations here at the Kennedy Space Center, checked with the managers of all of the cargoes on board, the tracking and data relay satellite, the Spartan Hallie, and various other experiments, and determined that all of them are go for launch. We have just passed the 13-minute point in the countdown. The TDRS satellite being placed in orbit itself weighs about 5,000 pounds and is the largest telecommunications satellite ever built. It spans 57 feet in orbit once its solar panels are unfurled and has two 16-feet single-access antennas. It operates in 3 frequency bands. NASA leases the satellite system from Space Communications Company of Maryland, and prime contractor for the satellites and the ground facilities are TRW Space and Technology Group and Harris Government Communication System of Melbourne, Florida. In orbit, the 2 TDRS satellites will be able to provide direct contact with the space shuttle about 85% of the time, compared with just 15 to 20% of the time for Earth ground stations. 11 minutes, 30 seconds before the launch. Contingency support operations have been verified to be ready for launch. A report being made to Houston that the visibility here at Kennedy is 10 miles or above 10 miles. T-minus 10 minutes, 55 seconds and counting. The flow rate of conditioned air being blown through the orbiter's payload bay has been verified to be approximately 180 pounds per minute, which is proper. Coming up on the 10-minute point in our countdown, just 19 minutes away from launch. T-minus 9 minutes, 57 seconds and counting. We're just a little less than 1 minute away from entering our last planned build-in hold in the countdown for the launch of 51L. The status of the vehicle is go at this time. Onboard computer programs have been examined and verified to be the proper ones. All aero surfaces and actuators that will steer the vehicle through powered flight are in the proper configuration for applying hydraulic pressure, and the flight crew has completed all of their cabin leak checks and communications checks with the launch team and flight controllers at Mission Control. Coming up on the 9-minute hold. 3, 2, 1, and we're at T-minus 9 minutes and holding. When the countdown resumes, the ground launch sequencer will be in full control. The master computer program will issue commands to perform the final critical tasks required to put the vehicle in the final launch configuration. It will also keep a close watch on as many as 1,000 different measurements each second during the final 9 minutes to make sure they do not fall out of the predetermined parameters. All personnel in firing room 3 here at Kennedy Space Center have now switched over to the same communications channel and will stay on that channel from now through liftoff. Launch of the 51L mission, planned for 11:38. Everything going very well in the countdown. The weather cooperating not only here but at other sites. We go to Mission Control in Houston to check on readiness there.
This is Mission Control Houston at the T-minus 9 minute mark. The flight controllers have been on console here throughout the night, the early morning hours, and are ready to support launch. All orbiter systems continue to function normally, and Mission Control is ready for the launch this morning. This is Mission Control, Houston.
Back here at the Kennedy Space Center, people in Mission Control watching all of their programs and making sure that we're ready to come out of the hold at the proper time. Although the 51L's primary mission is orbiting the tracking and data relay satellite and flying the Spartan Hallie spacecraft, many people around the country will think of it as the first flight of a private citizen. President Reagan determined that the private citizen should be a school teacher because of the great influence teachers have on preparing our citizens and determining the moral and intellectual future of our country. More than 11,000 teachers across the country applied to fly, and many of the finalists are at KSC to see their representative, Christa McAuliffe, launch on an adventure in education. While in orbit, 2 15-minute lessons will be broadcast on day 4 of the mission and carried live by PBS stations all over the country. This will enable schools which do not have their own satellite antennas to pick up the programs from the NASA satellites to have access to these broadcasts. And these will be supplemented by half-hour mission watch programs taught by backup payload specialist Barbara Morgan. In addition to the broadcasts, Mrs. McAuliffe will carry out 6 types of experiments on board, which will be filmed and videotaped for use in classrooms in the future. These activities include hydroponics, magnetism, Newton's laws, effervescence, chromatography, and the operation of simple machines. All of these experiments have been designed so that classroom teachers have easy and low-cost access to the materials used and can be easily duplicated here on Earth. Design of the experiments began back in August of '85 and concluded many ideas submitted by the applicants for the Teacher in Space program. One of the most exciting spacecraft on board the 51L mission is the Spartan Hallie Observatory. This is based on a low-cost bus which was developed by the Goddard Space Flight Center to fly instruments and provide attitude control pointing and that sort of thing, as well as recording of data for them. The Spartan Hallie mission is made up of many instruments which were recycled, some of them from the Mariner 9 spacecraft, which explored Mars in the early 1970s. The countdown clock at T-minus 9 minutes and holding. We should have a release of that hold at 11:29. This is Shuttle Launch Control. Test Director Ken Jenisek has completed a poll of the various test conductors, including those responsible for the vehicle, the spacecraft, the range, Mila tracking station, mission control, and has verified will be ready to come out of the hold at T-minus 9 minutes. That will be just about 4 minutes from now. A final go given by NASA Launch Director Gene Thomas. This is Shuttle Launch Control. The count will pick up in 3 minutes. Gene Thomas, Launch Director for NASA, has spoken to the crew and said that it's been a while getting here, but he welcomed aboard the nation's first private citizen and mentioned that it was good to see Mike Smith on the other side of the hatch. Mike Smith has been one of the astronauts who has been active here at the Kennedy Space Center as one of the team which helps prepare for these launches. He wished them a great mission and was responded to by Commander Dick Scobee, who said thanks a bunch and that they would see us when they got back. We're just about 2 minutes away from picking up the countdown at 11:29 with launch at 11:38 a.m. Eastern Time. Several major milestones remain between now and launch. As we come out of the hold, the entire countdown will be performed by the Ground Launch Sequencer program running in the Integration Console. The computer will control all the remaining countdown events as well as monitor the response and status of all the Space Shuttle systems. At T-minus 31 seconds, the Ground Launch Sequencer will issue a go to Challenger's onboard computers to start their own automatic sequence. The final command from the ground computers will come at T-minus 10 seconds, which will be a go for main engine start. We're 1 minute away from picking up the count for the final 9 minutes of the countdown in today's launch. The countdown simply a series of checks that people go through in preparations to ensure that everything is ready for flight. The countdown for a launch like the 51L mission is 4 volumes and more than 2,000 pages. "15 seconds away from resuming the countdown and looking at a launch of 51L at 11:38. And we're at T-minus 9 minutes and counting.
This has been initiated. 9 minutes and
The
counting.
ground launch sequencer program has been initiated.
Your APU brush recorders
JRPS will do.
and LPS place all fire room printer plotters online.
LPS copy.
And ISL, I'll need your verification when you get motion on the ops recorder.
No copy. STM 1015 was not performed.
T-minus 8 minutes, 30 seconds and counting. The flight instrument recorders are turned on. Mission control has turned on the auxiliary data system. This package collects data from the aerodynamic information coming back as the orbiter flies through the atmosphere. Coming up on the 8-minute point.
Ops recorders 1 and 2 running.
Copy that.
T-minus 8 minutes and counting.
Proceed with transmission of stored program commands.
Orbiter test conductor Roberta Wyrick has requested that Houston send the stored program commands, which is the final update on antenna management based on the liftoff time and sets the system which makes the orbiter compatible with downrange tracking stations.
Monitor, please.
Okay, that's complete.
T-minus 7 minutes, 30 seconds, and the ground launch sequencer has started retracting the orbiter crew access arm. This is the walkway used by the astronauts to climb in the vehicle, and that arm can be put back in place within about 15 to 20 seconds if an emergency should arise. Coming up on the 7-minute point in the countdown. T-minus 7 minutes and counting. The next major step will be when pilot Mike Smith is given a go to perform the auxiliary power unit pre-start. T-minus 6 minutes, 30 seconds and counting.
JRPS, start hydraulic brush recorders.
Roger, will come.
Coming up on the 6-minute point in our countdown.
APU pre-start.
OTC, PLT, SMR.
T-minus 6 minutes, and orbiter test conductor has given pilot Mike Smith a go to perform the auxiliary power unit pre-start. Mike has reported back that it's in work. He will configure switches in the cockpit to put the auxiliary power units in the ready-to-start configuration.
Pre-start is complete with 3 gray talkbacks.
Copy that, thank you.
Mike Smith reporting that pre-start is complete. T-minus 5 minutes, 30 seconds and counting, and Mission Control has transmitted the signal to start the onboard flight recorders. The 2 recorders will collect measurements of shuttle system performance during flight to be played back after the mission. Coming up on the 5-minute point, this is a major milestone where we go for auxiliary power unit start. T-minus 5 minutes.
Let's go for orbiter APU start.
TLT, OTC, perform APU start.
And we've had the pilot ordered to perform the APU restart. LOX replenish has been terminated and liquid oxygen drain back has been initiated. Pilot Mike Smith now flipping the 3 switches in the cockpit to start each of the 3 auxiliary power units. T-minus 4 minutes, 30 seconds and counting. The solid rocket booster and external safe and arm devices have been armed. We've had a report back from Mike Smith that we have 3 good auxiliary power units. Main fuel valve heaters on the 3 shuttle main engines have been turned on in preparation for engine start. T-minus 4 minutes and counting. The flight crew has been reminded to close their airtight visors on their launch and entry helmets, and a final purge sequence of the main engines is underway. T-minus 3 minutes, 45 seconds and counting. The orbiter aerosurface test has started. The orbiter flight control surfaces are now being moved through a pre-programmed pattern to verify that they are ready for launch. T-minus 3 minutes, 30 seconds and counting. Orbiter ground support equipment power bus has been turned off and the vehicle is now on internal power. T-minus 3 minutes, 15 seconds. Aerosurface checks are complete and aerosurfaces in launch configuration. Gimbal checks of the orbiter's main engines now underway. T-minus 3 minutes and counting. Gimbal checks now complete.
Let's go for EP-LO2 pressurization.
External tank liquid oxygen pressurization is started and purging of the shuttle main engines is terminated. T-minus 2 minutes, 44 seconds and counting. Retraction is started of the gaseous oxygen vent hood. And the ground launch sequencer will make a final check to make sure the vent arm is fully retracted at T-minus 37 seconds.
OTC, PLT, caution warning memories cleared, no unexpected errors.
Copy.
T-minus 2 minutes and 20 seconds, and we've had the pilot Mike Smith has cleared the caution and memory system. No unexpected errors reported. Liquid oxygen ullage pressure checks are underway, and the liquid oxygen tank approaching flight pressure. T-minus 2 minutes and counting. The liquid hydrogen replenish has been terminated and liquid hydrogen pressurization to flight level is underway. The vehicle is now isolated from all ground propellant and fluid loading equipment. T-minus 1 minute, 44 seconds and counting. Coming up on the 90-second point in our countdown. 90 seconds and counting. The 51L mission ready to go. The liquid hydrogen tank now at flight pressure and all 3 engines ready to go. Coming up on the 1 minute point in our countdown. T-minus 1 minute and counting. Sound suppression water system now armed. The hydrogen burn igniters have been armed. These igniters will be fired at T-minus 10 seconds to burn off any residual hydrogen gas. T-minus 45 seconds and counting. The solid rocket booster flight instrumentation recorders have gone into the record mode. Coming up on the 30-second point in our countdown. T-minus 30 seconds, and we've had a go for auto sequence start. The SRB hydraulic power units have started. T-minus 21 seconds, and the solid rocket booster engine gimbal now underway. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6. We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Houston now controlling.
Roger, roll, Challenger.
Good roll program confirmed. Challenger now heading downrange. Engines beginning throttling down now at 94%. Normal throttles for most of the flight, 104%. We'll throttle down to 65% shortly. Engines at 65%, 3 engines running normally, 3 good fuel cells, 3 good APUs. Velocity 2,257 feet per second. Altitude 4.3 nautical miles, downrange distance 3 nautical miles. Engines throttling up, 3 engines now at 104%.
Challenger, go at throttle up.
Challenger, go at throttle up.
1 minute 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles. Flight controllers here looking very carefully at the situation. Obviously a major malfunction. We have no downlink. We have a report from the flight dynamics officer that the vehicle has exploded. Flight director confirms that. We are looking at checking with the recovery forces to see what can be done at this point. Contingency procedures are in effect. We will report more as we have information available. Again, to repeat, we have a report relayed through the flight dynamics officer that the vehicle has exploded. We are now looking at all the contingency operations and awaiting word from any recovery forces in the downrange field. This is Mission Control Houston. We have no additional word at this time. Reports from the flight dynamics officer indicate that the vehicle apparently exploded and that impact in the water at a point approximately 28.64 degrees north, 80.28 degrees west. We are awaiting verification from as to the location of the recovery forces in the field to see what may be possible at this point. And we will keep you advised as further information becomes available. This is Mission Control. This is Mission Control Houston. We are coordinating with recovery forces in the field. Range safety equipment, recovery vehicles intended for the recovery of the SRB in the general area. Those parachutes believed to be paramedics going into that area. To repeat, we had an apparently normal ascent with the data coming to all positions being normal. up through approximately the time of main engine throttle back up to 104%. At about approximately a minute or so into the flight, there was an apparent explosion. The flight dynamics officer reported that tracking reported that the vehicle had exploded and impacted the water in an area approximately located at 28.64 degrees north, 80.28 degrees west. Recovery forces are proceeding to the area, including ships and a C-130 aircraft. Flight controllers reviewing their data here in Mission Control. We will provide you with more information as it becomes available. This is Mission Control, Houston. This is Mission Control Houston, repeating the information that we have at this time. We had an apparently nominal liftoff this morning at 11:38 Eastern Time. The ascent phase appeared normal through approximately the completion of the roll program and throttle down and engine throttle back to 104%. At that point, we had an apparent explosion. Subsequent to that, the tracking crews reported to the flight dynamics officer that the vehicle appeared to have exploded and that we had an impact in the water downrange at a location approximately 28.64 degrees north, 80.28 degrees west. At the time the data was lost with the vehicle, according to a poll by the flight director Jay Green of the positions here in Mission Control, there were no anomalous indications, no indications of problems with the engines or with the SRBs or with any of the other systems at that moment through the point at which we lost data. Again, this is preliminary information. It's all that we have at the moment, and we will keep you advised as other information becomes available. There are recovery forces in the general area, others being deployed, including aircraft and ships. We saw what we believe to be paramedics parachuting into the impact area, and we have no additional word at this point. We will keep you advised as details become available to us. This is Mission Control, Houston. This is Mission Control, Houston. Repeating our earlier information, for those who had not heard it previously, we did have this morning at launch time was approximately 10:38 Central Time. On launch, approximately a minute or so after tower clear, there was an apparent explosion of the orbiter. At the time, data was lost approximately a minute into the flight. That was shortly after throttle up to 104% of the 3 main engines. The flight director pulled positions, flight controller positions in the room later on and this morning, and was informed that there were no anomalous indications at the time. Tracking reported impact of the vehicle with the water. According to data, that was approximately 18 miles downrange at the time data stopped. Recovery forces being deployed to the field, were unable shortly to enter the specific area because of continuing falling debris, and at about this time are being admitted to the impact area. Contingency procedures are in effect, and following those procedures, all of the data available in Mission Control from the flight at the point or up to the point of the incident, data is being secured and will be carefully evaluated. We have no additional information at this time, and we'll keep you advised as other details become available. This is Mission Control, Houston.